I would like to talk about the electric potential energy. Before, let me give you a brief review of some physics concepts in Physics 1. First of all, I want to talk about the work, omega. The unit of the work is joule. Let's say we have a constant electric field between two plates. We have the left one has Q positive, and here we have Q negative. Between them, we have a constant electric field at any point. We have the same value of E. Here, I put at this position here a positive charge. Let's say I have the position 1. This charge is positive. So this here we will get an electric force applied on Q. This F must be in this direction. You know, in general, Fe equals to Q times E. If Q is positive, Fe and E have the same direction. Okay? You know, E is constant, so Fe is constant. Between this point and this point. Now I would like to study the motion of this object between the position 1 and the position 2. Fe will move the charge Q from this point to this point, so we have a displacement from here to here. Let's say in the X direction. In general, the work done by Fe equals to Fe times the displacement. You know the angle between delta X and Fe equals to O. So here we have Fe delta S cosine 0. We have Fe delta X. Here, if we have a constant value of Fe, and omega Fe is the energy consumed to move the charge from the position 1 to the position 2. Delta X is the displacement between position 1 and position 2. Now the object is moved to this point. At this point, I apply before, let me write here, equals to Fe x2 minus x1. Now at this position, I will apply an external F applied on the charge by an external agent, F agent. This FA pulls the charge Q back to the position 1 slowly from here to here. Okay, so FA is applied from position 2 to position 1. The work done by FA equals to, here we have a displacement from here to here, which is equal to x final minus x initial. Okay, FA have the same direction to this displacement. So we can say we have FA times x1 minus x2. We can say here equals to minus FA x2 minus x1. Here in this case, I apply FA only slowly on the object. The value of FA equals to the value of FE, but in the opposite direction. As magnitude, we have the same value, but as direction, it's opposite. As you see here, omega FA equals to minus FA x2 minus x1, and omega FE equals to plus FE x2 minus x1. So as FA equals to FE, we can say omega, the work applied by FA, equals to minus the work applied by FE. Okay, you have to remember this relation between the initial position to the final position. Now I want to take another case. The case where F applied electric F is not constant. So let's say we have a point charge. Positively charged at a point P here. We have a field EP. The magnitude of EP equals to K, Q, let's say capital Q, divided by the distance square. Here we have capital Q. And here we have position 1. We can say here, let me say position 2. Position 2. And here capital Q, and we have nothing at the position 2. Here at the position 2, we have E2. If we put a charge here, a positive charge with small q, we will get an electric force F. Let's say F1, 2. You know, F1, 2 equals to the field as a point 2 times the deposited Q times Q, small q. We can say absolute value, and here we have K, Q, capital Q divided by the distance square between 1 and 2. Okay, between 1 and 2. This is F12, but this F is not constant if we go away from capital Q. Let's say the charge here, capital Q, has a fixed position, constant. It cannot move. The charge capital Q will push the small q away from the position 2 to the position 3. So here we have the object will move from here to here. So here we have a displacement between this position to this position. Let's say we have delta x. As f is not constant, so the work done by f equals to the integral between 2 and 3. We can say here we have x-axis. So between x2 and x3, here we have f1, 2 times dx. You know the angle between f12 and dx equals to O. So here equals to x2, x3, f12 times dx. We can substitute the value of f12 by, we can say small q times E. Also, E is not constant. E will change along the path. So we have QE times dx here between x2 to x3. This is in general. Also, when the object moves to this position, to this point, to get back this object, this charge, I have to apply FA. Okay? FA as magnitude, FA equals to F12 or F21, or in general equals to F electric. Okay? So omega FA equals to minus omega FE. This is the external agent applied on the object. We apply the same calculation, but here you have to know, in the case of a variable f, the work done equal to the integral of f times dx. Okay? This is the first point important about the work.